All right. Does it say that we're going to write both sides with the same base? Okay. All right. And so the thing is I know it's been a while since we've seen these, so this is a good review anyway. Even if you did well on the test, you probably forgot. All right. So that common base would be 3. Okay. So this one, the left side is already written with 3. Okay. Now, all right, and y'all do this while I'm working these problems. Y'all try to work ahead of me. Okay. And we'll try to go slow. But you got to keep in mind, we got to do 14 problems in 50 minutes. Okay. Now, all right, 3 to the 4. No, or yeah, 3 to the 4. 4x minus 4. Okay. All right, now I got it right. All right, now, y'all need to be quiet. Okay. How much credit I'm giving back tomorrow, I don't know. Half credit, full credit, 0.1% credit. All right, now, all right, so if the bases are the same, the exponents are equal. I don't really think anybody had any issues with this type of problem. Okay, so what we said, somebody said what now, the 3's don't matter, do they? Okay, so we just get 4x minus 4 equals 4. All right, and we shouldn't need any help solving it from there. Okay, y'all pick it up and solve it from there. Tell me what you get. I think it should be 2. Okay. All right, if you don't get 2, say something. We'll get somebody to help you, okay? All right. Now these numbers don't correspond to the ones on the test exactly here, but this next section from 2 through 7, let's say a vocabulary term here. What kind of an equation do we call this? Fun one. No. Okay. Right. What's unique about the unknown? What is the unknown in the equation? It's a what? It's an exponent. Okay. So this is an exponential equation. So was the first one. But on the first one, we wrote both sides with the same base, and you can't do that here. Now, what I was saying is that this little section here, 2 through 7, we probably need to focus more on these than any other ones on the whole sheet, because this is where most of you guys had a lot of trouble on your test. Okay? So, y'all actually, most of you did pretty good on the log equations. The exponentials really got you here. Okay? Now, look at the directions. I know they're not on the smart board, but look at them on your paper. Okay? It says solve the following exponential equation. Now, here's a really good hint on how to solve it. The next sentence says express the solution set in terms of natural logarithms. Now, I don't see any natural logs there. Do you? No. Okay. So that tells you that's something that you have to introduce, don't you? So since you can't write both sides with a common base, you take the natural log of both sides. And I actually think most of y'all did pretty good on this first one. It was the ones that followed that kind of got you. Now, before we take the natural log, remember there's a little something we're supposed to check for first? Before I take a log or a natural log on both sides, you got to isolate the base. But this one's already isolated, right? So when we say isolate the base, if I had like 4 plus that, I would subtract 4 on both sides. Or if I had 4 times that, I would divide 4 on both sides. But that's not the case. So now we're going to take the natural log on both sides. Now, see if y'all can kind of remember from here. And again, I'm trying to let you work ahead. All right. So yeah, the x goes to the front by the power property. Okay. So when is it that I don't really have to use the power property on this step right here? When this base right is e right there. Okay. So if that was natural log of e to the x instead of 3 to the x, it would just be x. Okay. But it's not e to the x. It's 3 to the x. So we use the power property. So right here, it's one of two things. It's either the power property, or remember we called it the Ricky Bobby property. Okay? All right, so we move this to the front. Okay, and now we can solve it. All right, so how do we solve it? Divide by natural log 3. Okay. Now, this is the answer in terms of natural logs. All right, and that's what the direction said, right? Okay, put the answer in terms of natural logarithms, but then what else? Okay. Use a calculator to obtain a decimal approximation to 2 decimal places. All right, now, if you guys don't mind, I'm not going to do the calculator part. We should know how to punch that in the calculator. Now, the harder ones I'll pull up the calculator and do for you. Okay, but we should know how to punch that in the calculator. All right, now, let's look at number 3. Okay, now, big difference on number 3. All right, you got to isolate first, and plus on this one, the base is E, so we don't have to use the power property. Okay, now, all right, but we have to isolate first, right? So what do you mean there? What do we got to do? Yes, divide by 9. Okay. Now, let it divide by 9, 2 nines, that's no big deal. Okay, so we'll get e to the x equals 23 over 9. All right, now it's isolated. Okay. All right, now what? Take a natural log on both sides. All right, y'all do that. Okay, take a natural log on both sides if you didn't know what to do from there. Well, you still do it to both sides, but what you're saying is you don't use the power property. Okay. Right. Very good. All right. Get the s. Take the natural log on both sides. But then the natural log of e to the x is just x. That's why we just said, on number 2, we didn't do that, did we? On number 2, we used the power property. But on number 3, we got a base of e, so we don't need to. So this is just x. Okay. Yes, via the Ricky Bobby problem. Okay. So here's my exact answer here, or the answer in terms of natural logarithms. Okay. Now, and you can type that in and see what that is. Okay. Now, notice you don't type in this. This is not the natural log of 23 divided by natural log of 9, is it? Okay, it's just natural log of 23 over 9. So be sure you type that in right. All right, you ready to do number 4 now?
Sure.
All right. We're okay? All right, so here we go. Another base of E. Okay, now you got to isolate it first, but is that one isolated? Yeah. Okay, our base is E, and it's isolated, so we'll take the natural log on both sides. All right. So, power property or no? No. Okay. So the natural log of e to the 3 minus 5x would be 3 minus 5x. Okay. And that equals the natural log 1002. All right, subtract the 3.
But you don't keep it with natural log, you subtract the 5.
All right, so let's talk about subtracting this 3, because we know we got to solve for x right there. All right, now when we subtract this 3, all right, and I think some of y'all kind of made fun of me when I proposed this when I taught you, but some of you did it. Some of you would say 1002 minus 3, and y'all would put 999. No, why not? Because it's the natural log of that. Okay? And y'all got to understand the natural log of something, when you take a log of something, that is an exponential operation. And we do exponents before we subtract, don't we? That's why you can't do that. Okay, so it's really tempting to do that. Now that leaves me with negative 5x equals natural log of 1002 minus 3, like that, right? Okay, so not natural log of 999. Okay? All right. Now what? Divide by negative 5. Okay. Now, all of that by negative 5, right? Okay. Now, that's my answer in terms of natural logs. Now, let's talk about pushing this in the calculator. I'm going to pull this one up. Okay. All right. All right. Y'all help me type it in, or tell you what, y'all type it in. Type it in, and then I'm going to type it in and see if you knew how to do it right or not. So remember when I told you about typing this in, that's really, really helpful? Instead of thinking of like dividing by negative 5, you can type it in as a fraction, and that way you don't have to worry about it. Because let's just talk about it just a minute. I'm going to type it in the hard way first, okay? So if I type it in like this, natural log of 1002. Now we know we should close that parenthesis, okay? And then minus 3 over negative 5, and this is not going to be right. Okay? So what's wrong with that? The only thing that's being divided by negative 5 is negative 3. Okay? So how could I fix it if I were going to keep it in that format?
Just do the net minus 3 times. I get the answer like natural log 1002 minus 3.
Yeah, and it equals. I didn't think about that. Y'all see what he's saying? Yeah. You would type in the natural log of 1002 minus 3 and hit equals, and then divide by negative 5. Okay? Let's talk about other ways to do it. Okay? How could I tell the calculator to divide all of it by negative 5?
The alpha.
Right, the fraction thing. All right, here's what I'm trying to get you to see or tell me, is to put that in parentheses. Now, ultimately, it's better using the alpha F1. Okay? Yeah, it's much better. Okay? So that's, that wasn't going to be right. So that's ultimately the easiest way to do it is to type it in using that. Okay? All right, so we type it in. Make sure y'all got it right, okay? All right, natural log of 1002. Okay, got to close that parenthesis. Because listen, what happens when I don't close that parenthesis is it subtracts 1002 minus 3 and then does the natural log. Okay? All right, so minus 3 and then divided by negative 5. Okay? All right, so how many decimals? 2? All right, so negative 0.78. Okay? All right. Now, let's do this one. Isolate. Okay. All right, work it out. All right, so you would add 4. Now, could you actually add 4 to 26,903? Yeah, because it's not natural log of that. Yeah, it is. Okay. All right, so unlike this one, this one didn't have any isolating. This one you got to add 4. After that, it's pretty much the same thing. Okay, it's really just like number 4, except for you have to do this first. Okay. All right, y'all try it on your own from there. Okay, since it's so similar. Ah, surely did, didn't it? Okay. All right, so what is that? 7? Okay. All right, thank you, appreciate that. All right, let me see if I can tell you the answer in my head. All right, I'll wait. Have you added the 4 yet? Okay. Making sure you're that far.
You did it wrong.
He did it right, but and the 3, he can't add the 3.
All right, so you should get the natural log of 26,907 plus 3 all over 2. Okay. All right. Let me work it out just in case. Okay. I'll go kind of fast. All right. Natural log on both sides. Okay. And so when I do the natural log of e to the 2x minus 3, it's just 2x minus 3. Okay. Now, it's just isolate next from there. So you add 3 and then divide by 2. Now, when we add 3 right there, we're not going to add 3 to that and get 26,910, are we? Okay, because that's the natural log. So we get 2x with the natural log of 26,907 plus 3. Okay, and then all over 2. Okay, so I'm just going to do this. All right. And that is approximately, okay, now we just talked about how to push that in the calculator. The best way was the fraction template, okay? So I'm not going to worry about punching it in. I'm going to let you do that. All right. Now, number 6. Okay, now, all right, notice the differences. we went from a base of E, now we're back to a base of 3 like number 2 is it. Okay, so what we don't use that Ricky Bobby property. Okay, now is our base isolated there? Yeah. Okay, so I don't have to do any isolation. All right, so now you do natural log of both sides. All right, y'all do it. Okay, you try. Go ahead, Kevin. Okay, please. Yeah. This should be like in parentheses at the top. Okay, or that way, all of that. All of it. Right, that's what you have to do. You isolate the log and you switch it to exponential. So the e to the 7. Divide by 8. Get 2. Squared. All right, let's look. Let me see if you got it here. All right, so we're going to jump to this. All right, and listen, don't forget about this. A lot of times, you know, the reason of why we're taking the natural log is so we can do the power property. But if you do it to one side, you do it to the other. And we know that, but there's a lot of careless mistakes made by people who won't do it to the other side. It's not because they don't know better, it's just, it's careless. Okay? Because, you know, we're really focused more on this side, and that's why we forget about doing it to this side. Now, so this is not This is not going to be 0.8x right here, because this is not a base of e. Okay, so we use the power property and bring it to the front here. So 0.8x times natural log 3 equals natural log 519. Now, this step, it kind of gets people, because you're isolating x, and you have two things, and really what you have to do is you have to get rid of both of them in the same step. Okay. Now they're multiplying, so since both of them are multiplied, we divide off both of them. Okay. So what I mean by both of them, watch. We would divide by 0.8 natural log 3. Okay, does that make sense there? Because I'm multiplying x by both of those values, then I divide by both of those values. Okay, and see, that's going to get x isolated over there and solve for. Now I've got to divide the other side by the same thing. Okay, so 0.8 times natural log 3. Okay. Now, see that'll cancel. That'll cancel. And just got x there. So there's my answer in terms of natural logs. Okay. And a lot of people miss this one on the calculator too. Okay. And let me just let you know something for when you get your paper back tomorrow. I think these were 6 points apiece. So this answer right there, that's worth 5 points, and then the other one's only worth 1 point. Okay, because to me this is more important than typing stuff in the calculator. But you still have to know. So what I'm saying, there was like a couple of you in here, and I think it was let me see, Morgan. I think you missed this like a couple times. I don't know if that was you or not. Now I know Marley. See, in Marlon, you didn't have like anything right there, but it wasn't that bad on you, because you got 5 out of 6 points. Okay. All right. I was just trying to show you how I graded that, so you know when you get your test back. Now let's type it in the calculator the correct way. All right. Just look. Now, do y'all want to use the fraction command there?
Yes.
Yeah, much easier to do when you use the fraction template. Even though it's not really a fraction, it's division, you can still do it. All right, natural log 519 divided by 0.8 times the natural log of 3. Okay, so about 7.11. Okay. Okay. Now, this one's really similar to that last one. Instead of a base of 3 or a base of e, it's a base of 9. Okay? But it does look like a g. All right. But it's not a base of e, is it? Okay, so no Ricky Bobby stuff. You got to use your power property. Now, all right, listen, concentrate. Is it isolated though?
Yes.
Yes. Okay, so we can go ahead and do natural log on both sides. Okay, so natural log 9 to the x minus 2 equals, now don't forget to do it on the right side. Right, now power property. Okay, so x minus 2 times natural log 9 equals natural log of 223. All right, so let's talk about what we do. Do we add 2 here? All right, now, I probably should have done this. Now, normally when we solve with parentheses, we kind of distribute and get rid of the parentheses, but that's kind of going backwards a little bit. All right, so what you want to do, you want to get rid of that natural log first. Okay, so you divide that, and then we subtract the 2 off. Or not subtract the 2, add the 2. Okay, all right, here we go. Now, the next thing is like really crucial about how we're going to add the 2.
The E
right, to the end of it, right? All right. Now, kind of catch up with me because I'm gonna pose some questions. I want you to tell me which one. I'm gonna write three different answers. I want you to tell me which one is right. Okay? Yeah. So, all right. So what about that or all right, the last one? Okay. All right. Y'all see why it's that? Why it's not this one? Yeah, you can't add 2 to 223 there because that's the natural log of 223. All right. Now, what's wrong with this?
I don't know. I just
Add it to the top, that's the whole thing.
Okay. Right. That's only adding it to the numerator. Okay. We have to add it to the whole thing. So the plus 2's got to go out over here on its own. Okay. All right. So, not putting that plus 2 in the right spot ruins your problem. Okay. Now, y'all want to type it in the calculator real quick, or you want to move on?
Yes, sir.
You want to type it in the calculator? That's fine. We can do it. All right. Anything else? All right. Now, listen. All right. You want to use fraction command again? Really, you wouldn't have to on this one because that plus 2 is separate. Okay. I'm just going to use division on this one. All right, but you certainly could use your fraction. Okay, divided by natural log 9, and then plus 2. Only thing is you got to be sure you're closing your parentheses on your natural log. All right, so approximately 4.46. That's a nasty 6. All right. Now, all right, from here, most of you did pretty good. Okay, so I'm going to go a little bit faster, let you probably work more on your own on these. All right, number 8. Now, these are log equations. Now, let's back up 1 second. Okay, when we have a log equation, if it's a single, well, let's just start off with this. Okay, the biggest key here is to go to exponential form. Okay. Now, what are some other potential problems that I have to do first, maybe? You might have to do what first? Isolate. Okay. If it's multiple logarithms, like on number 11, if it's multiple logarithms, what do you have to do? Combine them using your properties, product and quotient properties. Okay. The other thing is there's some cases where you don't have to go to exponential form. All right, what's that case? See if y'all can kind of answer that. If it's a natural log, you're probably still going to exponential form. All right, look at 13 and 14. Yeah, logs on both sides. So if it's logs on both sides, you don't go to exponential form, but you cancel them off. Now you got to get them combined first. Okay. Well, number 13 and 14, you would combine first. All right. Now let's do number 8 and 9. Now on 8 and 9, the thing here is both of these are natural logs. Okay. So the thing that we have to use is their base is an understood what? E. Okay. Where's the 10 coming from? That's the common law. That's just log plain law. Okay. Not natural law. All right. So this understood base right here is E. All right. So remember this. All right. For the 100th time, log base B of x equal y means b to the y equals x. Remember when I told you I introduced you that the first day and I told you 2 weeks from there I'd be fussing at you about it? Yeah. Today's that day. Okay. All right. So this is going to be what? E to the 7th equals x. Now, the way the directions are worded, it says to what give the exact answer. That's the exact answer. Okay. And then round it to 2 decimal places. Okay. So we just type that in the calculator. All right. E to the 7th. All right. So 1096.63. All right. Okay. Talk to me here. You okay? Yeah, we could do that, but I could like trap you into getting the wrong answer, and you'd have to figure out how to get away. Hey, I did. Hey, true story. I did give a trig test a couple weeks ago where I gave them the answers to the questions, but they had to show the work to get there. All right. Now, this one's really similar. It's just got a couple of steps in there that you got to do first. You got to isolate first. You got to get rid of that 8 first. Okay. So what do we do about that 8? Divide. All right. That's pretty simple. Okay. You get natural log 6x equals 2. All right. Now we go to exponential form. Okay. So that would be what? E squared equals 6x. Right, divide by 6. Right. So there's our exact answer. E squared over 6. And then you put that in the calculator and approximate it. I don't know what it is. Okay. Y'all can do that. All right. Y'all agree with our 1.23? He punched it in?
Yes.
All right. All right, number 10. Okay. Now, so from 10 on, no more natural logs. They're either common logs or logs base 2 or base 5. Okay, whatever. Now, so with a single log, you isolate it and then you go to exponential form. Now, it's already isolated. Okay, so all you got to do is go to exponential form. I don't really think many people miss this one. Okay, so 2 to the 5th equals x plus 24. And 2 to the 5th is 32. Okay, subtract 24. All right, that's 8. Now remember how we have to check for extraneous solutions there? The logarithm has to be positive. So not x, but x plus 24 has to be positive, and that would be positive. Okay. All right, it's usually when you, y'all be quiet. It's usually when you start using your properties when you get stuff with extraneous answers. Okay. All right. Number 11. Now, let me tell you something that happened on your test here. I believe it was this problem that was on the test, or one very similar, where it looked like in between that it was a minus sign, but it was actually a plus sign. So you guys that took it early, which was like on Wednesday, I went ahead and let it go with the minus sign and just graded it like it was. Okay, but it was supposed to be a plus, but you really couldn't tell. It was very, very light. Okay, you had to look right, really close. All right, but anyway, I'm going to get y'all to correct that tomorrow. Okay, now, so what about this plus sign? And there's 2 logarithms there. Right, you got to multiply it, so you got to FOIL it out. Okay, so you have to use your properties to combine those 2 logarithms into one, and then you just turn it into a problem like number 11 or number 10 was. Okay, all right. So this would be log base 2. Now let's FOIL that out. So this times this. So that would be x squared minus 5x minus 3x plus 15 equals 3. Okay. Yeah, combine your like terms. So the negative 5x and negative 3x would be negative 8x. Okay. Now, let me show you what happened on a lot of these. Not so much this year, but years past. Here's what I've got. All right, that's really tempting to do. That's not right. Now, what happened to the log there? All right, so I need to do something with that logarithm. All right, what do we say? What? Go to exponential form. Okay, so not this, but not x squared minus 8x plus 15 equals 3, but it should be equal to what? 2 to the third power. Okay, so it should look like this. All right, now look at that. See? All right, here we go for the 1013th time. What? Look up. This number raised to this power equals this number. Okay? All right, now that's 8. Okay, now look what we got there. Right, I want it set equal to 0 because it's a what? Quadratic. Somebody said it. Okay, quadratic. Nope. Nope. There we go. All right, now, how we factor? X minus 7, x minus 1, x equals 1. All right, now, this is usually on these quadratics, not 100% of the time, but most of the time, one of the two will be extraneous. Okay, so go back to the logarithm. Okay, x minus 3 and x minus 5 has to be positive. Now, if x is 7, would x minus 3 and x minus 5 be positive? If x is 7, yes, they would be positive. Okay, all right, but not 1. All right, so that one's okay. But if we put 1 in, 1 minus 3 would be negative 2, so it would be negative there. So what do we do with 1? Yeah, X it out. He's extraneous. Okay, so you can circle this one, X that one out. All right. Now, look at 11 and 12 collectively. Okay, together. Now, they're very, very similar, right? All right, there's one big difference. What makes all the difference in the world here? Subtraction as opposed to adding, right? This right here, instead of multiplying, we would divide it. Okay? We get log base 5 x plus 13 over x minus 11 equals 2. Okay.
No.
Well, we can move on to other stuff and not redo this test.
Whoa, wait.
5 to the 2 power.
All right.
So the 2 power.
Let's say 5 squared. That just makes it sound smarter.
She said 5 to
5 to the 2. Okay, 5 squared. That's okay. It's the way Emma would say it. My Emma, not you. 5 to the 2. All right. So 5 squared equals x plus 13 over x minus 11, and that's 25. Okay, now how do we solve that?
put it over 1 and cross.
Yeah, cross multiply. Now I need some help. What's 25 times 11? All right, thank you. All right, and then 1 times x plus 13 is x plus 13. Okay. Cross multiply. Okay. Now, it's not a quadratic, is it? You don't need to set it equal to 0 and factor it. Just solve it, okay? So I'm going to get my x's together. And that's 24x. All right, and then add 275. 288. Yeah, that's right. And then 288 divided by 24, like 22 maybe? I don't know.
It's 12.
12. Now, let's check it. And it's probably okay, right? But, all right, if x is 12, are those positive? Yeah. So we're good. Okay. All right. Now we got logs on both sides. So we got to think ahead on logs on both sides. We're going to cancel them off. But look at me. Somebody did this. I promise you. We'll make fun of them if I find out who it is. No. All right. So, and then somebody did this. They just went like that. That's not right. Okay. So this is plus, right? So multiply. So log of 11x. Okay. And this one's log of x plus 11. Now they cancel. Okay. All right. Now, track that. All right, we okay there? All right. Are we on the last one finally? Thank God. All right. You do the last one, and then I'll do it. Okay? Yeah, sure. Eleven over 10. That's it. Yeah. All right, I think that's 8 over 7, but I did that in my head, so that very well could not be right. 8 over 7? Dang, I'm good. I did it in my head. Oh. All right. All right, look up if you didn't get 8 over 7 real quick. Now, mine is right there, so we're going to use the quotient property. Is that right? Okay. All right, and now we can do this. All right. And now what can we do? Cross multiply. All right, so x plus 12 equals 8x plus 4. All right, subtract the 4.